As Suat said, I'm currently working in Amsterdam, but the project which I'm going to talk about is something which has been made during my PhD mostly. I'm very excited to be talking to you about bilingualism as a brain-changing experience. And as you can see in the title of the talk, I used the word tale, a tale of brain-changing experiences. And then I was interested in, if it's a tale, how would it be if there were a kingdom where only bilinguals or multilinguals live? And I asked AI, artificial intelligence, to help me create this kingdom. And that's just the result so basically this is what a kingdom of multilinguals would look like. This project wouldn't have been possible without the help and guidance of my supervisors during PhD, Janine Dreyfus-Daller and Christos Pratsikas, and I would like to give a warm shout out to these two amazing people who helped creating this project. So we are speaking about bilingualism. Bilingualism has been suggested to modulate our brain and cognition. And these findings have energized the discussion on possible neurocognitive benefits induced by use of two languages, like modulating creativity, attention, or even better cognitive aging and neural reserve. But the problem is that many of these findings appear inconsistent. And as a consequence, this has led to questioning the robustness of results of bilingualism, effect of bilingualism on our brain and cognition. And I think it's a little bit preaching to the choir maybe, but it's important to understand how and whether bilingualism changes our mind and brain, because it's central to sensitive topics in our society, such as education or migration. If we understand how bilingualism changes our brain, it could open the door to include bilingualism as an intervention in clinical practice, and also demystify bilingualism as a negative developmental factor in children. So if I speak about inconsistencies, what can we do about this? So out in the field, people have been doing many things to address inconsistencies in bilingualism research. And some of the solutions include careful group selection according to the bilingual experiences, realizing that not all the bilinguals are the same. Then also investigating the contribution of the individual bilingual experiences on our mind and brain. And last but not least, also thinking about bilingualism as a continuum, as a spectrum of experiences, and not thinking in binary terms that someone is bilingual or not. And in this project, I would like to add to this list something which I think might help, and that's biological principles of experience-based neuroplasticity. And even though it might sound a little bit heavy, wait for it. I will explain further what I mean by this. Overall, in today's talk, I will then be using these solutions which have helped to address some of the inconsistencies to shed more light on how bilingualism changes our brain structure. So if we are speaking about bilingualism as an experience which can change our brain, let's talk about how experiences change our brain in general. So brain usually can provide the functional supply to manage our behavior and thoughts, but some experiences can be so demanding that our brain is not used to deal with them, and it creates a mismatch in the functional supply of the brain, and as a consequence, the brain changes. And this has three crucial ingredients. First, the cognitive demands of the new experience need to be high so that it exceeds the functional supply. It also requires time so that the brain can assess, okay, it's worth trying to change for this experience. And these two things then can lead to structural brain changes. And as you can probably infer, bilingualism ticks all the boxes. So use of the two languages triggers the need to choose between competing alternatives, which comes with the cognitive demands. It's a long-standing experience, often a lifelong experience. So not surprisingly, bilingualism is, I dare to say, well established as an experience which can prompt the brain to make new connections and grow. But the brain cannot grow. And it's not only that there are some obvious physical limitations, such as we cannot have larger brain than ourselves. Oh, here's someone. Oh yeah, sorry. But also, if you think about nature's solution to adaptability and increasing efficiency, it's not a never-ending growth. If you think about the Darwinian principle, the most suitable individuals are selected, whereas the other individuals do not make the cut. And that's maybe something which brain does also with experiences. So one of the principles of experience-based neuroplasticity is the expansion and renormalization. So if we start learning a new language or another skill, our performance increases until it hits the ceiling and then it stabilizes. And here you can see the estimates of the regional gray matter volume, which we measure if we measure the brain volumes. And as you can see, the brain reacts to learning new skill by creating new connections. And once we reach the peak efficiency, the superfluous neural resources are eliminated and the volume renormalizes either partially or completely to the baseline levels. So this is something which we know from other experiences like music learning or writing with the other hand, but it hasn't been connected with bilingualism in studies so far. And there are also some important points which I would like to highlight. So if you take, for example, someone who started to learn a language and someone who is proficient in this, if the expansion or normalization model holds true, the brain volumes would appear for these two individuals as equally large. And another thing is behavior and brain structure do not map onto each other because they have different trajectories. So to understand behavior changes caused by experiences or by bilingualism, we should look also at the brain and vice versa to make a point. So according to these biological principles, neuroplasticity resembles auditioning. So if you were about to make a Hollywood movie and were looking for the best leading actress, you would invite many candidates for your auditioning. So this will increase the chance that among the many candidates you find the one perfect for the role. At the moment when you find the best actress, you will send the other people home because you don't need them. And that's something which my brain might be doing too. In the context of bilingualism, a recent model incorporated these principles, a theoretical model, to propose a theory about how bilingualism changes our brain. And that's the dynamic restructuring model developed by Christos Platsikas. And this theoretical model for bilingualism specifically has two key principles, which are important also for us to decide how to approach brain changes induced by bilingualism. So first, the quality and quantity of bilingual experiences governs the brain changes. So to reveal the effects of bilingualism on the brain, it's necessary to assess bilingual experiences as continuous variables. And structured brain changes are expected to be dynamic. So to reveal changes in the brain, it's probably necessary to use a method which can model the nonlinear effects of experiences on the brain. So weaponized by these theoretical models and principles, I would like to move to the empirical part of my talk, where we try to make use of these theoretical principles. So I will talk about three studies in which we looked at bilingualism through the lens of experience-based neuroplasticity to investigate how bilingualism changes our brain. And there are three objectives: to explore bilingual experiences and their dynamic effect on the brain. Then also we uncover how the brain changes differ in different bilingual groups. And in the third study, I will look at one specific bilingual experience, code switching, and its effect on the brain structure. So for these three studies, we collected data of 114 Czech native speakers, and they were bilinguals, Czech English bilinguals. And these people can be also divided further in three groups: Czech English bilinguals without professional experience, but then we had also specific bilinguals, interpreters, and translators. And we applied a bunch of other inclusion criteria to make sure that our sample is balanced in terms of education and also comparable levels of English as a second language. So in the first study, we looked at the bilingual experiences in general bilingual experiences and their dynamic effect on regional brain volumes. And specifically, we looked at volumes of basal ganglia, which are important structures for bilingualism, as had been shown in previous studies. If I speak about the general bilingual experiences, we used the language and social background questionnaire, which is a questionnaire which creates composite scores of bilingual experiences. And these scores are created by combination of proportion of frequency use, the proficiency L1 and L2 in various, also the use in various contexts for various topics, code switching frequency, you name it. So it's really comprehensive score, and it's highly weighted on the language use. And it gives a composite score, which then can be used as a continuous variable. In the data analysis, we use generalized additive mixed models, which is basically similar to linear mixed models, but with the power to model also nonlinear relationships. And in the analysis, we use bilingual experiences as predictors of gray matter volumes of the basal ganglia, the structures which are important for bilingualism and have been shown to change in bilinguals. And here are the results. So here you are looking at graphs featuring the brain volumes on the y-axis and the bilingual experiences on the x-axis. And we also controlled for age on the z-axis. And as you can see, for the codet, which is a structure important for selection of languages, submitting which languages are going to be necessary to control for, and also for switching, we see that at the beginning of the bilingual experience, the volumes start to grow. So in the participants which are at the beginning of their journey in terms of the bilingual composite score, the volumes of codets grow until they reach a point after which we see that high experienced bilinguals have small volumes of codet. And as you can see, the trajectory resembles the expansion partial renormalization trajectory. So for codet, we can see an evidence for what might be interpreted as the expansion renormalization trajectory. For accumbens, which is a structure helping us to stay motivated and which is highly interconnected with codet, we see expansion and then plateauing pattern. So again, with it seems that the brain volume of this structure increase with the growing bilingual experience and then plateau. Then we have also looked at putamen and thalamus, and there we can see linear increase of the volumes of putamen and thalamus. And we could interpret this finding that as bilinguals, it's in our group, just did not need these structures that much to maybe renormalize, or it can be something which can be said about the structures itself. Maybe these structures don't undergo renormalization as we saw in the previous two. But what's important, we see that with growing bilingual experience, these structures grow, and this was a significant effect. As for the functionality, the putamen is very important for articulation and controlling for articulatory schemata, and the thalamus is a structure which helps us deal with high cognitive demands, and we will come to these structures also later. So this is for the first study on the general bilingual experiences and brain structure. In the second study, we looked at the brain changes in bilingual professionals, interpreters, and translators. And the question was whether the trajectories of brain volumes differ in these three structures, which also use the two languages in quite some different ways. In the data analysis, we used the general bilingual experiences, as you saw in the previous study, the LSBQ. But then we looked at effects of these experiences in each group differently. In other words, we wanted to see whether bilingual experiences have different effects in groups which qualitatively differently use their two languages. We used also Bayesian statistics to test our hypothesis. And why? Because if we, in frequentist approach, this would allow us to only reject the null hypothesis, while with Bayesian modeling, we can also speak more about the real trajectory of the volumes. So not only rejecting the null hypothesis. In this study, we looked at two structures which have been identified in functional studies on interpreters and translators as important. And also, so that's the putamen, because it controls the articulatory control and simultaneity, and codet, which is thought to be important for all bilinguals. And we see in many studies that this structure, if any structure is going to undergo changes in bilingualism, you might as well be looking right at this one. So it would be important for all bilinguals. And here are the results of the second study. So you're looking at graphs with 3 columns for each of the investigated groups: interpreters, translators, and bilinguals, non-professional bilinguals, and 2 rows for volumetric trajectories of the putamen and codet. And on the y-axis, you are plotted the volumes of the structures, and on the x-axis, the bilingual experiences. And as you can see, the volumes were normalized clearly only in interpreters. Here we can see that the confidence intervals are really broad. So even though we see some normalization pattern, we can't say whether it's just due to a chance. I would say that because interpreters use the 2 languages the most intensely, this might suggest that the intensity of bilingual experience or the quality of bilingual experience also matters, and not only the quantity. So the brain structure of interpreters who need to engage with both languages under immense time pressure, but not necessarily more often than the other groups, reach quicker the efficiency in handling 2 languages, and the brain has time to choose the most suitable connections. And I would like to illustrate it in the following example. So the translators and interpreters use both languages qualitatively differently, but as we can see in our sample, the scores for the bilingual experiences were very comparable for these 2 groups. I would like to remind you that interpreters need to deal with the simultaneity in their jobs, and this is not something which translators need to do that often or need to do that intensely. And simultaneity is something which has been shown to be subserved by putamen. So here we can see that putamen normalizes in interpreters, but not in translators. And I think it reflects that interpreters have extensive training in processes subserved by this structure. So this structure can therefore undergo the process of auditioning for the most useful connections in interpreters, because the brain has enough time and opportunity to choose the most efficient connections, even though the level of bilingual experiences was very comparable in the two groups. And then comes a third study where we looked at structural neurocorrelates of habitual code switching practices. And I would like to just illustrate on this small example what code switching is. So it's a bilingual act in which bilinguals switch between their two languages within one conversation, and sometimes even within one sentence. And this is an example of a Czech-English code switch, and it's not refinement of my imagination. It's really what a student at the University of Reading wrote in a social media conversation. So you can see that it's almost impossible to say whether it's a Czech or English sentence. So here we were interested in this study in how this bilingual act and engagement in this bilingual act changes our brain. So if you recall, the structural brain changes occur if we engage in some activities which are cognitively demanding. And code switching has been shown to induce some cognitive demands or needs to be cognitively costly. But code switching comes in many forms, and not all of them are equally cognitively costly. And one of the characteristics we need to consider is directionality of the switch. So here are two examples of a code switch which differ in the directionality. So switching from N1 to L2, Sheldon to pick up his clothes, or from L2 to L1, in case for our study, he went home vyzvednout si oblečení. And studies show that the switching from L2 to L1 should be more cognitively costly than the other way around. And I'm saying it here, and I'm going to park this idea about the directionality, because for the sake of time, I won't be presenting the results on the directionality, but it's something if you are interested, we looked at, and it's a preprint of this study. But what I will talk about today is level of separation of the switch, because that's another factor which we should consider when we think about code switching as a cognitively demanding experience. And there is this theory called inhibitory control continuum, which posits that the more separational code switchings we have, the more inhibitory control it requires. And here you can see some code switching examples which differ in the level of separation. And you can look at the gray black bars here which represent the two languages, to see a quicker orientation of how intermixed the languages are in one sentence. So here we see that there is a huge level of separation in insertion. We can see that there's just one word inserted in the whole sentence. And then we have also the dense code switching when it's the participants or the speakers switch really freely. We also introduced the code switch beyond the inhibitory control continuum, the intersentential code switching, which is maybe even more separational than the alternation. And it's basically switching between two sentences. So the question remains, are these cognitive demands of code switching types going to be reflected also in the brain structure? And there are two structures important for code switching, as has been shown also in clinical studies, and that's the coded nucleus and thalamus. And as you might know by now, the coded nucleus is important for bilinguals in general, and it's also very important for switching in general. So not only language switching, but also switching. We think that this structure might be sensitive to all code switching types. And then we have thalamus, which deals with very demanding cognitive control processes. So we think that this structure might be more sensitive to the more separated forms of code switching. So what we did, we asked participants in our study to rate how often they encounter code switches like these in their lives. So we had all these code switching types in terms which differ in terms of the separation. These were presented audio visually, and then we asked participants to rate how often they would encounter these authentic examples from conversation of Czech English bilinguals in their everyday life. And what we found here is just an overview how the frequencies played out. As you can see, the three code switching types, alternation, intersentential code switching, and insertion, were pretty much used in similar ways. But the dense code switching was a little bit of an outlier. So our participants did not really engage in the dense code switching, the very intermixed form of code switching. And here are the results of how code switching types influence the brain structure of these two gray matter volumes, the gray matter volumes of these two regions. In the first row, you can see the results for the codet. And as you can see, for overall code switching frequency, this structure grows. So we can say with the more participants engaged in code switching or said that they engage in code switching, the bigger code volumes they have. And then we also looked at the directionality, and we can see that these also for both directions from L1 and L2, the codet structure grows. For thalamus, we can see that this effect was not significant. So we didn't find an evidence that with more code switching, the thalamus structure will be different, even though we can see some trends, but this is not statistically significant. But then we looked at also at the different code switching types. And as you can see here, are each row are the different code switching types ranked according to this level of separation, to high separational code switch, to minder separational code switch, and in terms of the cognitive costs, to more cognitively costly and less cognitively costly. And as you can see, for the almost all code switching types emerge as significant predictors of coded volumes. In case of dense code switching, it might be not the case because the participants did not engage that much in this type of code switch. And for thalamus, only the two most separational code switching types were predicted the thalamus volumes. So the most cognitively costly code switching types were related to changes in thalamus volumes. So our finding confirmed that codet is likely important structure in code switching, as use of almost all code switching types and overall code switching was positively related to larger coded volumes. And as for the thalamus, the changes were significantly predicted by use of the cognitively more demanding code switching types. So I would like to try to bring these three studies together in a small discussion. So I hope I have convinced you, if you weren't convinced already, that bilingualism is a dynamic, multifaceted experience, and as such induces dynamic changes in behavior and for now, in the brain, in the case of our studies. And we observe the nonlinear changes in brain, and we think that this might explain also variability in results to date. So maybe, the nonlinearity is a way forward in putting in a picture the brain changes induced by bilingualism. I think that these studies also show that specific bilingual behaviors train cognition in different ways, and therefore it induces different changes in brain regions to link to the type of behavior. So I think it's important to consider the types of bilingual experiences when we are thinking about how they are going to change the brain structure. And I think that there are 3 points which can be taken for future studies. So first, I would like to argue that make mental space for the possibility that the world around us is not linear. Then I think it's necessary that we continue treating bilingualism as a continuous variable, and that we also might want to combine cross-sectional and continuous approaches, because I think that the study of the interpreters and translators shows that it's still necessary until we know what how exactly bilingual experiences play out in the brain, to still consider bilingual groups, and it might help us to phenotype to identify bilingual phenotypes. I would like to just make at the end, almost at the end of this presentation, a little bit view to the future, sight to the future. How can we use this? We try to use this knowledge in a subsequent project where we are looking at how bilingual experiences can serve as a protective factor against Alzheimer's disease. And we will be looking also at the individual code switching experiences as a possible way that it might play out more or differently than other experiences. And I would like to also thank at this point to all the people on the way which helped create this project, beyond my lovely supervisors, which I mentioned before. And I would like to gratefully acknowledge the funding which I have received to make this project and these studies possible. And at the end, I would like to say that thus the bilingual experiences modulated brain and mind happily ever after. And I would like to, I'm really looking forward to hear your questions if you have any.
Hey, thank you so much. All right, we have a lot of questions in